Here, let's do two questions. The average daily temperature T of a city in the United States is approximated by this model. T temperature equals 55 subtract 23 times cosine 2 pi over 365 times temperature T minus 30, where T is in days and T is in between 1 and 365. 1 and 365 are included, and T is 1 corresponds to January 1st. We want to find the period of T. Okay, so before we do that, we want to look at the general case. First, cosine x has this picture. You see, red one. Okay, and we know that cosine x complete one period in just from 0 to pi. It will complete one period. And then it repeats the pattern from 2 pi to 4 pi. It repeats the pattern. So that's why we say cosine x has a period 2 pi. But how about cosine x, cosine 2x? Here is cosine x. What's the period for cosine 2x? Cosine 2x, previously for cosine, when it reaches value 1, 0, negative 1, 0, 1, 1, 0, negative 1, 0, 1, it reaches at the point 0, pi over 2 pi. You see, 0 maximum, pi over 2 is 0, and then 1x is pi, you have negative 1. So 1x choose pi, you have negative 1, and then going up. Okay. Now here, what does 2 play? You see, because every value multiplied by 2, every x value multiplied by 2, and behind cosine x. So every x multiplied by 2, it goes to 2 pi faster, because every value is multiplied by 2. For example, when x is pi over 2, you put here, u times 2, it goes to pi. When x is 3 pi over 4, u times 2, it goes to 3 pi over 2. So then you choose cosine. You have a cosine 3 pi over 2 is 0. So actually, if you have a 2 here, it reaches 2 pi faster, twice as faster than this one. Okay, so you see 1x is pi, and then times 2 is 2 pi. You then choose cosine 2 pi is 1. Cosine 2 pi is 1 right here. Okay, so that's why you see, if you have a 2x here, it reaches 2 pi faster. Then this actually leads to the period smaller, because you choose x value, when x is pi, 2x reaches 2 pi, and cosine 2 pi is 1. Okay, so then you have to do is the period is actually changed from 2 pi here for cosine x to pi. 2 pi. So cosine 2x actually has shorter period. What does this 2 play? This 2 plays is as a denominator. If you have a 2 pi always is the period for cosine x, you divide it by 2, you will get period for cosine 2x. So that's the reason 1 here is 2. You always use original period 2 pi divided by 2. Then a natural question is what? Is here is 2 down on denominator, which will be 1/2 times x. That's the same. Because here previously it multiplied a number 2, which is greater than 1, so you reach 2 pi faster. But here you multiplied by multiplied by 1/2, which is less than 1. So it made the whole value behind cosine slower. In order to reach 2 pi, you have to put 4 pi here. Because 4 pi divided by 2 is 2 pi. 4 pi divided by 2, or 4 pi multiplied by 1/2 is 2 pi. So 1 here, you have a coefficient less than 1, then it made the value behind cosine x goes to 2 pi slower. The formula will be what? 2 pi divided by 1/2. Always coefficient of x to divide the given period, 2 pi. You know the details are right here. 2 pi divided by 1/2 is 2 pi times 2 over 1, and which is 4 pi. Okay, so then go back to this place. Here, t minus 30, right now we do not want to consider what the meaning for minus 30. We just want to be sure that before the coefficient t, because 2 pi over 365 is distributed to t, okay? And 2 pi over 365, of course, is distributed to negative 30 as well, but you know, right now we just want to consider in front of this quantity t minus 30, we want this coefficient 2 pi over 365. That's the number we wanted as a denominator, and 2 pi divided by 2 pi over 365 is 365. The reason is similar. You do the division, you get 365. That's why we say the period for this one is 365. Here we find the period already, 365 days. Okay? All right. We may do this question later. I'll see you next time.